Hello everyone, myself Pranjal Sharma. Today's video is completely on a new topic, units and measurements. For the new viewers, I have a suggestion that I have made videos on vectors and scalars. Please watch them. I have added the link into the description. Okay, so today's topic is units, unit and measurement. Unit and measurement. So in generally in physics we study a system which have certain properties. So those properties can be measurable, and the quantity which are used for measuring the properties of the system are known as physical quantities. I have also discussed physical quantities in my lectures on vectors and scalar. Now, physical quantities, suppose we want to measure degree of hotness or coldness of a system, or we want to measure distance between 2 points, then there are certain physical quantity which, with the help of those quantities, we can measure the exact value. Suppose I want to measure the temperature of a boiled water. So we know that temperature of boiled water is 100 degrees Celsius. So if we omit this part, then only 100, this is a simple numerical value. It has no meaning until and unless we add this quantity, degrees Celsius. Similar, or we can express it in different scale known as Kelvin, 373 Kelvin. So Kelvin is also associated with temperature. Similarly, I want to measure distance between 2 points. If I write, suppose the distance between 2 points A and B is 10, but this value unable to reflect all the informations. We have to add some quantity, suppose 10 meter or 10 kilometer. So then, only then it will give all the informations about the distance between 2 points. So physical quantities can be expressed in terms of numerical values as well as some suitable reference. Those references are known as units. So here degree Celsius, Kelvin, or meter or kilometer, these are all units. Now, these physical quantities can be subdivided into two types. In my earlier class, vectors and scalars, I have classified physical quantities according to their presence of direction, and where I classify them as vectors and scalars. Here we will not classify them according to their directions, but here we will classify them how we can measure those physical quantities. Suppose I want to measure mass of a system. Then the mass of a system is, if we want to loosely define mass, then we can say mass is nothing but the amount of matter contained within the system. Or we want to measure the distance between 2 points, or we want to measure the degree of hotness or coldness of a system. So there are some quantities which directly associate with them. Suppose I want to measure degree of hotness or coldness of a system, then there is a quantity known as temperature. Suppose I want to measure the length between the distance between 2 points, then it is a quantity known as length. So this mass, length, time, temperature, all these quantities are directly measurable. You don't need any other physical quantities to express them. So these quantities are known as fundamental quantities. Fundamental quantities. Similarly, some other quantities, which suppose I want to measure speed of an object, then speed, according to definition of speed, the amount of distance covered by the object per unit time. So speed equal to distance by time. So distance, there is a quantity associated with them, or length, and time is obviously. So length and time are the two physical quantities with the help of we can measure speed. So these kind of quantities which can be expressed with the help of other physical quantities are known as derived quantities. Derived quantities. So there are two types of fundamental quantities we found, two types of physical quantities we found. One is fundamental quantities, other is derived quantities. Fundamental quantities are sometimes also known as base quantities. So physical quantity are classified into fundamental quantities and derived quantities. The units associated with fundamental quantities are known as fundamental units. So fundamental units are associated with fundamental quantities. Derived units are associated with derived quantities. So an example of fundamental quantities are mass, length, time, etc. So an example of derived quantities are speed, force, momentum, and so on, etc. In this way, we can classify physical quantities according to their measurements. Now, these fundamental units and derived units are together considered as system of units. So, system of units includes system of units. It includes both fundamental units and derived units. There are three systems of units. One is known as CGS, another is MKS, and third is FPS. So actually these three units are named after the unit associated with three fundamental quantities known as mass, length, mass, and time. In CGS unit, it is the unit of length is centimeter. The unit of mass is gram, and time is second. So centimeter from C from centimeter, G from gram, S from second. In case of MKS, the unit of length is meter, mass is kilogram, and time, the unit of time is second. So M from meter, K from kilogram, S from second. In case of FPS, length is from foot or feet, mass pound, poundal, and time second. So F from foot, P from poundal, S from second. So there are three types of units. Since there are three types of units, so there was some problem which unit should be used in practical purpose. So in 1971, General Conference on Weights and Measurements in 1971 recommends a international system of units which is known as SI units. SI units. So it is international system of units. SI units means international system of units, according to which there are 7 fundamental quantities. So in SI unit there are 7 fundamental quantities. Actually it is the extension of MKS system. In SI unit the fundamental quantities are: number 1, length; number 2, mass; number 3, time; number 4, electric current; number 5, temperature; number 6, amount of substance; and number 7, luminous intensity. So the unit of length in SI system is simply meter, mass is kilogram, time is second, electric current is ampere, temperature is Kelvin, amount of substance is mole, luminous intensity is candela. So these are the 7 fundamental quantities, and 7 fundamental units. These are also known as base quantities. These are known as base quantities or fundamental quantities, and these are known as base units. I have added the definitions of these quantities. If you want to learn the definition, pause the video and watch it. Beside this, there are 2 supplementary units. Supplementary units are associated in this system. One is supplementary. supplementary units. One is planar angle, simply angle. Another is solid angle. Solid angle, one is angle. So angle, unit of angle is radian, we all know it. And angle of, unit of solid angle is steradian. Steradian. So solid angle means the angle formed in a cone shaped object. So solid angle is like this. So this is solid angle, and it can define, it can represent by Greek letter omega in general. Okay. So this is solid angle. Normal angle is, this is a normal angle. Suppose this is generally represented by theta. Okay. We have learned that the physical quantities can be classified into two types. One is base quantities, another is derived quantities. The unit associated them are for base quantities are base units, for derived quantities for derived units. And we have also learned a three system of units: MKS, FPS, and CGS. And finally we have learned SI system, where 7 base quantities are associated, and also learned their units, and along with them we have also learned 2 supplementary units. Now we have to learn another thing. We often measure length in centimeters, kilometers, or millimeters. So here, since we know that meter is the unit of length, but here centi, kilo, milli, so these are actually these prefix terms are known as multiples or submultiples. So we have to learn multiples and submultiples used in units and measurements. So multiples are those quantities, those prefix which means the positive, which associate positive power of 10. Suppose I want to measure kilometer, kilometer. So meter means, so in this kilo means 10 to the power 3. And if I want to measure millimeter, again in the meter is the unit of length, but milli means 10 to the power minus of 3. So it is known as multiple, and it is known as submultiple. So I have added all the multiple and submultiples into the screen. So pause the video and watch the entire table. Then you will learn all the multiples and submultiples associated with measurements. So now we will learn the measurement of first 3 fundamental quantities, actually length, mass, and time. So measurement of length. Here measurement of length. Look, if I want, so length means the distance between 2 points. So length may be anything. It may be minutely small to a large size of the universe, or if I want to measure the diameter of an atom, diameter of the nucleus, or size of a molecule, or if I want to measure the diameter of a sun, or distance from Earth to a certain star. So the length may vary from a very small scale to a large extent. So there are numerous ways to measuring length. For small measurements in day-to-day life, we often use rulers. In general, rulers is a simple scale which which you find in the instrument box have a least count. That is, it can measure a minimum length of 1 mm. But you have in day-to-day life you have to measure some length which are much smaller than millimeter. So for this we use different instrument like vernier calipers, spirometers, screw gauge, etc. For if you want to measure a size of an atom or size of a molecule, then you have to rely on technology in that time. So you have to rely on instrument like electron microscope, tunneling microscope, etc. And if you want to measure the distance of a star from Earth, then you have to measure it by different method. We often use a method known as parallax method, through which we can measure the size of a star as well as distance of the star from the Earth. So for small instruments, small measurements means day-to-day life in general, we want scale, vernier calipers, screw gauge or spirometer. Atomic, if you want to measure atomic scale, atomic size, then we use instrument known as electron microscope or tunneling microscope. If you want to measure large distance, suppose you want to measure large distance of a star from Earth, then we use method known as parallax method. Parallax method. Okay, now we will learn the parallax method. So parallax method is basically associated with the distance of a star, measuring a large distance. That is, if you want to measure the distance of a star from Earth, then this method is applicable. Now, parallax. So in this method, suppose this is a star and this is Earth. Suppose I want to measure, if I want to observe this star from this point. From this point, suppose this point. And if we observe the star from this point also, after watching it from this point, then we move to this point and then I watch it again. So there is an angle made by, suppose this is a position A, this is position B. So there is a certain finite distance. Suppose this is a small d, the distance between 2 points. The angle made by these two lines is, suppose, some theta. So this is a star S. So let d be the distance of star from Earth. If d is very greater than b, if the distance of star from is very greater than the distance between these two observational points, then you can calculate, or you can consider it a small arc. You can consider it D as a small arc and then D equal to, we know that in a circle, suppose this is center, this is the radius, suppose I want to locate a point from the center, then this is the radius R of the circle. Suppose the point moved from this point to this point, then, and this is also R, so angle made by them is theta. Then if the displacement from point to point is ds, so ds equal to what? Ds equal to, or S, so S equal to R theta. Similarly, in this case, D equal to, small d equal to capital D into theta. So from this you can measure D equal to small d by theta. So here D can be measurable because we know the distance between 2 points, so we can easily calculate it, and we also calculate theta. So with the help of these two values, we can measure the distance of star from the earth. Now with this, since we know the distance of the star from earth, now we can measure the diameter of the star. How? Let's see. Suppose this is a star and this is the earth. Suppose I want to measure the position of this. I want to observe these edges of the star. Then I also see these edges of the star. Then the angle between them is, suppose, some angle alpha. Again, so these 2 points are diametrically opposite. So this is so this length is diameter of the star. Since we know D, we can calculate alpha also. Then again, if this is the diameter, suppose diameter is D prime. D prime is the diameter of the star. Then D prime is equal to, simply we know that D into alpha. So with the help of this value, you can calculate the diameter of the star. So this is the parallax method. In general, the distance of a star from the earth is very large, so we have to use some large units. So in this case, we use some length units. Some of them are mainly astronomical unit. Suppose one is astronomical unit. Astronomical unit is nothing but the average distance between sun and earth, which is approximately 1 AU is approximately equal to 1.5 into 10 to the power 11 meter. So it is actually 1.496 into 10 to the power 11 meter. So we can, for calculations, we can use this round figure 1.5 into 10 to the power 11 meter. Similarly, this is astronomical unit for large distance. Unit for large distance. Astronomical unit. Another is light year. Light year. So the distance, we know that the distance of the speed of light is what? C equal to 3 into 10 to the power 8 meter per second. Actually 2.998 into 10 to the power meter per second. C equal 3 into, in general we can write C equal 3 into 10 to the power 8 meter per second. So distance covered by light in 1 year is known as light year, and its value is 1 light year equal to, it is nearly 9.46 into 10 to the power 15 meter. 9.46 into 10 to the power 15 meter. So beside this, there is another unit known as parsec. Parsec. So what is parsec? We know that Earth revolves around the Sun in an elliptical orbit. So this is the Sun and this is our Earth. So in parsec, the distance at which average radius of Earth orbit makes an angle 1 degree. 1 degree is known as 1 parsec. So its value is 1 parsec is equal to 1 parsec. 1 parsec is equal to 3.28 into 10 to the power 16 meter. 3.28 maybe. No, 3.08. 3.08 into 10 to the power 16 meter. In general, often use there is a one relation you often use in astronomy where 1 parsec is approximately equal to 3 light years. So this relation is often used in astronomy. Now we have learned the measurement of large distance and their units. For suppose I want to measure the length of the size of a nucleus, diameter of an atom, or size of a molecule. In this case, we use some units known as, one is known as Armstrong. Armstrong. 1 Armstrong is equal to 10 to the power minus of 10 meter, and generally Armstrong is represented by this figure, A and dot on it. It's a round figure. Circle on it, small. And similarly, if we want to, Armstrong is usually used for calculating the size of an atom. If you want to measure the size of a nucleus, the size of a nucleus is very small compared to size of an atom. So in this case, we use a unit known as Fermi. Fermi. 1 Fermi is equal to 10 to the power minus of 15 meter. So these two units are for small length measurement. Small length measurement. Okay. I have added the chart of different size of different objects in this video. pause the video and watch it. So now we learn the measurement of mass. Measurement of mass. So in general, mass can be loosely defined as amount of matter contained in the object. Object of a mass is amount of matter contained in it. Okay, we can loosely say it, but often the mass is a very complex thing. So if you in higher physics, there are certain things which you have to learn about mass, but here it is an introductory class, so you don't need to learn about them. So in generally, we use balance to measure mass. If you want to go grocery shop or vegetable market, then you actually count these things. You can suppose you want to buy 2 kg of potato, then you simply found that the seller actually use electronic balance or a manual balance to give those quantities, to measure those quantities. Now, so mass of an object may vary also from very small size to a very small value to a large extent. Suppose mass of an atom is very small. Mass of an suppose mass of our star is sun is approximately 10 to the power 30 kilogram. 2 into 10 to the power 30 kilogram. Mass of our earth is approximately 10 to the power 25 kilogram. If you want to calculate mass of an electron, then its value is 10 to the power minus 31 kilogram. And this electron, this is earth, this is sun. And if you want to calculate mass of proton, then it's 10 to the power minus 27 kilograms. So all these, look, this value and this value, these are very large compared to these things. Electrons, protons have values which are 10 to the power minus 31, that is 31 zeros. After that some digits will come after decimal points. Okay, so a large range of mass available in our universe, from electron to our observable universe. The mass has different range of values. So in generally, in atomic level, you can measure mass by unit known as unified atomic mass unit. So unified atomic mass unit, U. So 1 U is equal to simply 1 by 12 of carbon 12 atom mass. Carbon 12 atom mass, which is approximately equal to 1.66 into 10 to the power minus 27 kilogram. 1.667 actually. So 1 U, with the help of this unit, you can calculate the mass of an atom, or so on. So I have added the different mass of different objects in a chart. Please watch pause the video and watch it. Similarly, in case of time, we can also, we need to also measure the time. So if you watch the definitions of the units, then you find that how we can calculate a second. Actually, it is associated with the vibrations of cesium atoms. Okay, so please watch that part where I have discussed on the definitions. I have put a chart on all these things. Pause the video and watch that things. Then you will understand which unit defined what. I have added the different range and order of time interval of different events. Pause the video and watch that chart. Then you will understand, or you can correlate under what scale our universe working, and how our day-to-day life is influenced by time, and so on. So in today's video we have learned units and measurements are different we have learned physical quantities and their units. We have learned two types of physical quantities. One is fundamental, another is derived. And also we have learned the measurement of different fundamental quantities, mass, length and time. We have learned different system of units, MKS, FPS, CGS, and also SI units, different base quantities for SI units. We have learned the definitions of them, as well as we have learned how we can use different units for different scale of length, different scale of mass, and different scale of times. So at this point I want to stop this lecture. If you like this kind of content, please like the video. You can share the video. If you want more this kind of content, please subscribe the channel. Thank you.